Hey guys, let's get started on section 2 of chapter 4. Prokaryotic cells. They lack a membrane-bound nucleus. They have a central nucleoid region where DNA is, but not a true nucleus. They are smaller and more simple than eukaryotic cells, which have a true nucleus. Prokaryotic cells can be broken down into two taxonomic domains, bacteria and archaea. Bacteria cause disease, but they are also important as decomposers in the environment. They break down dead material. They can also be useful in manufacturing different products and drugs. Archaea live in extreme habitats. They are structurally similar, bacteria and archaea are, but biochemically different. The structure of prokaryotic cells, they are very small, 1 to 1.5 nanometers wide, and about 2 to 6 long. They occur in 3 basic shapes: spherical, rod-shaped, and spiral. They have a cell envelope, which contains a plasma membrane, a cell wall, and I can't say that word, guys, sorry. The plasma membrane is a layer of phospholipids that we talked about in the last chapter. It also contains proteins that are embedded all the way through and some that are only found on one side. This plasma membrane can form internal pouches which increase its surface area. The cell wall maintains the shape of the cell and is strengthened by peptoglycan. And there is a layer of polysaccharides on the outside that is very hard to remove. Here are the structures, a good visual. I believe this is included in your notes. Here is the structure of the plasma membrane. Here are those phospholipids, okay, the glycerol with the fatty acid tails. Remember, the bends or the kinks are caused by unsaturated fatty acid tails. Where that bend is, there is a double bond. These are the proteins that are embedded. This is a protein that goes all the way through, okay? And this is a peripheral protein that only exists on one side. Here we have a generalized diagram of a prokaryotic cell. You can see the nucleoid region. This is where the DNA is, and it's all coiled up in one long circular strand. These little dots, the little dots right here, those are ribosomes. That's where proteins get made. We have fimbriae, which are hair-like bristles. The plasma membrane is this blue guy right here. Directly outside that is the cell wall, which helps give its shape. And then we have the capsule, which is a gel-like coating that gives it a little bit of extra protection. And then over here on the right is an actual image of an E. coli bacteria. And down here at the bottom, we have a flagellum. The plural is flagella, and this is how the E. coli moves around. Prokaryotic cytoplasm and external structures. The cell is filled with cytoplasm, which is a semi-fluid solution. It's encased by the plasma membrane. It contains water, inorganic and organic molecules, and enzymes. It also contains a nucleoid region, the prokaryotic cell does, where it contains the DNA, a single circular DNA molecule. That is not all the DNA that is in there. There are small pieces of accessory DNA called plasmids. There are ribosomes, where proteins are made. External structures, we have the flagella, which provide motility, make it mobile, let it swim around in its environment. Fimbriae, which are small bristle-like fibers that sprout from the cell surface. And conjugation pili, which are rigid tubular structures used to pass DNA from cell to cell. So bacteria cells will join up together. They'll say, hey dude, I got some good DNA, you want it? And they will transfer that DNA using this conjugation pili. And that is it for prokaryotic cells, guys. If you have questions, let me know.